Welcome to the 8th video, Art of the Forecast, Predicting an Uncertain Grid. We have spent 6 chapters building a toolkit, almost 7 now. We pointed at the one thing energy fuel craves most, to know the future. But here's the trap. Ask a beginner to forecast tomorrow's demand and they hand you a number. 4,200 megawatts at 6 in the evening. Confident. And almost exactly the wrong thing that you can say. Because the one thing we know for certain about number is that it will be wrong. The real question was never what will demand be. It is how sure are we and what is the fall range. Forecasting done well is not about predicting a number. It is about honestly describing your uncertainty. So as you can see, not a number, a range, and the time spans across the timeline. So let me make that concrete. A point forecast is a single line reaching into the future. One base case is there. The probabilistic forecast is a fan, a shaded band, most likely here but plausibly anywhere in this range. And in energy, that band is not nicely, it is the entire decision. But here's why. If you knew tomorrow's demand exactly, you would schedule exactly enough generation, not a megawatt more. But you don't know it exactly, so you hold reserves, expensive backup, spinning and ready. To cover the case where demand runs high or the wind suddenly dies. And how much reserve do you hold? Just enough to cover the width of that fan. A narrower, more honest forecast means less reserve held in waiting, real money, and real emission saved. The value was never in the guess. It is in the width of the band around it. As you can see, moving on, there is not one forecasting problem. There are many stacked by how far ahead you look. Seconds ahead, solar farm watching for the next passing cloud to smooth its own output. Minutes to hours, the ramp of wind and sun for keeping the grid balance right now. A day ahead decided which plants to switch on tomorrow, the single most valuable forecast in the system. Days to weeks, it's kind of scheduling maintenance, buying fuel. And seasons ahead, we are talking about how much capacity to build for next summer's peak. So like that, every one of these is a genuinely different problem, different data, different physics, and different right answer. So the tool that nails the next 10 minutes is not the tool that plans next year. Remember that very clearly. And now, something rather lovely happens. This is where the entire series comes together. That gradient boosting workforce from chapter 2, it's actually a good forecast that they had load forecasting. And the recurrent and temporal networks from chapter 3, the backbone of short-term wind and solar. The generative models from chapter 4, Jedcast, dreaming up weather ensembles, Chronos forecasting unseen series. All forecasting, all are forecasting. So, every method we have built has been quietly a way of predicting the future. Forecasting is the application they were all secretly pointing at. But if forecasting is really about honesty, then how we score a forecast is everything. For a point forecast, we measure the average error, mean absolute error, or its percentage cousin. Simple enough, but beware. Percentage error quietly explodes when the true value is near zero, which is precisely what happens to solar output at dawn and dusk. A careless metric can lie to you, actually. And for probabilistic forecast, single error won't do. You need to reward a model for being accurate and honestly uncertain, in other words. So the tool for that is pinball loss, also called the quantile loss. So as you can see in the screen, it punishes you gently when reality lands inside your range and harshly the further outside it falls. It rewards the forecast that is narrow when it can be and wide when it should be. This is not academic. The global energy forecasting competition of 2014 made probabilistic forecasts, and as well, scored by pinball loss, the benchmark across load, price, wind, and solar. Let us ground all of this in the very case we opened the series with. So, in 2019, Google and DeepMind pointed a neural network at 700 megawatts of wind farms, as you can see, and forecast their output 36 hours ahead. 5:36, that is the window that lets you promise the grid a day in advance what you will deliver, actually. And a promise is worth far more to a grid than a gamble. By forecasting well enough to commit, they raise the value of that wind energy by roughly 20%. Sit with what created that value, not more wind, not a single new turbine. So, same with just a better forecast and confidence to commit to it, actually, just from knowing it sooner. Which is the perfect moment to stop talking about methods and start looking at the world. We have built the tools. We have seen the single most valuable thing they do. So, let us go and see them and stay tuned for the next video. 5 real systems ahead of you. Thank you for hearing me out.